Well, we're just about ready to wrap this John Audio Tech Zarbo Audio Projects speaker design up. If you've watched the 4 previous videos, thank you, I appreciate it. But now, let's take some measurements and see what we're working with sound-wise. At this point, John's speaker cabinets are physically finished and veneered, just awaiting crossovers. Remember, John has identical drivers and will be using his to populate the cabinets once I deliver them to him. I'm running short sine sweeps with my Dayton OmniMic to generate frequency response files that I can import into the XSIM crossover program. You can also pause and take a snapshot of what the OmniMic is hearing, which is handy. Here's a pic of the tweeter's response with the bass frequencies removed. This is the woofer response. Both of these are called far field measurements, so 20 inches or so away from the tweeter center. And here's a sweep of the woofer near field measurement, which is basically taken as close as the microphone can get to the woofer's dust cap, quarter inch away or so. These two graphs are kind of cool to compare because you can easily see how the room is interacting in frequencies below 300 Hz or so. I think I mentioned it previously, but the actual cabinet itself is around 0.8 cubic feet or 22.7 liters interior volume. And the drivers we're using are the Dayton DC200-8 woofer and the Dayton DC28F tweeter, both available from Parts Express. It is a sealed design, and so you might be wondering, how low can it go, bass-wise? Well, to determine that, we look at the model, and we can see that it has a predicted F3 of 53 Hz, an F6 of 41 Hz, and an F10 of 31 Hz. And I can tell you that this design has plenty of bass. That sounds good. These are both older budget-minded drivers, so you also might be wondering how much bass this design can produce before it starts to go south. The woofer specs state that it has 4.5 millimeters of one-way excursion. So here's a graph that shows where the X-max is breached, all the way down to 32.4 Hz at an input of 15 watts. Well, 15 watts might not sound like a lot, but if I put the full wattage capability of the woofer, we can see that the driver would totally destroy itself. Excursions sky high. So we have to use a more reasonable power figure to get real-world predictions. This is not meant to be a crossover tutorial. My XSIM skills are somewhat lacking, to be honest. I really need to check out Tweed's DIY Audio YouTube channel and rebrush up on the process with his XSIM videos. I basically imported my measurements in XSIM as is, and between some rudimentary simulations and part swapping over the span of a few days, I managed to get a pretty decent sounding crossover worked up. This is what it ended up looking like. It's probably not perfect, but after a few days of listening, I felt that I had eliminated any major issues, and I decided to stop messing with it. You know, you eventually do have to stop twiddling with these crossovers and just solder the dang things together. I'm happy with it. No matter what kind of music I threw at it, nothing really made it sound harsh, even at loud volumes, so that's a win for me. I assembled all 4 crossovers at the same time, since I had the soldering iron hot. I have just a few things to do before I get these installed and ready to take to the Parts Express speaker design competition, where I would meet John and hand these off. Getting ready to button these things up, and one of the things I want to do is put a little black inside of the driver recess. This has 1/8 of an inch of hardboard, which is pretty dark. So I don't need to do that for the tweeter. I set it in there and you couldn't see anything light colored. For the woofers, just a little bit. So what I tried using a magic marker, it didn't work. So I got a little bit of painter's touch from Rust-Oleum flat black paint. I'm just going to brush a little bit in here, try not to get any on the finish. Again, you're not really going to see this. It's just going to be dark instead of having a lighter color hue to it, if you do happen to just catch the right angle. Yeah, touches like this, they take a little bit of extra time to do, but I think they really raise the overall quality of the finished product. The 1/8 inch hardboard that I used to face this cabinet out with provides enough of a dark area where you can't see any light through this. This is a pretty tight fit. But one thing we do have going on here is that, I mean, that's pretty good. It's a little more recessed than I think I want it to be. Maybe, I don't know, not even a 1/16 maybe. But I think I'm going to put another layer of some kind of material down, gasketing material, maybe craft foam, just to bring that out just a little bit, because once it gets screwed in, it's going to get torqued in just a little bit. Might be overkill. I might not use it after I make it, but I think I want to try it. All right, so I found a few pieces of this black 1/8 inch craft foam you get from the dollar store. It's fairly rigid, somewhat, I would say somewhat compressible. I'm not going to do a big thick gasket like this on it. I'll do something a little less. This is the safety cover. As it ships, it comes in this cover, so it's hard to see that line. I don't even know if you can pick it up, but it's there. So let me get my scissors and cut that out real quick. So I'm gonna try to cut this. I gotta get my glasses. I can't see nothing without my glasses. These glasses are the worst. I got them super glued, epoxy, hot glued. I don't know why I just don't buy a new pair. I really should. Not the prettiest thing ever, but hey, maybe it'll work. Well, no, that doesn't do the trick. You know why? Because as hard as I can press that, it's still too high. See that? If I press that down, I can't press it hard enough to get it flush, so I guess that's not going to work. Plan B might be to just reduce how thick this is so it compresses easier. Put that in there first. No, that does not work at all. Even that little bit doesn't want to compress. It's just too thick. All right, plan B. I think we're up to plan C there, big guy. But let's take it easy on him. He is a little frustrated. It's okay though. We're about to get this thing all wrapped up. In case you haven't figured it out yet, the entire reason I have to build up the tweeter a bit is because when I made the recess, I made it a smidge too deep so I could use my handy router veneer trimming bit. This allowed me to machine the recess and openings before applying the veneer. But it also created this slight issue. But like I said, a little of this 1/16 inch gasket tape did the trick, thankfully. Oh, that's looking promising. Oh yeah, look at that. Once I get the screws in and get that torque down, that's going to put it almost perfectly flush. Nice, I like that. Problem solved. See, this has a plastic faceplate, this tweeter, and it only has 3 holes. So it tends to flex. When you get this hole and this hole squished down, if you're compressing a gasket material, this part here that's unsupported by a screw tends to, not press down quite as hard, but this is just a very small amount of gasket, and I think that's probably gonna be perfect. All right, good. I did end up adding some additional gasket material on the woofer openings as well. Not for any particular reason other than I just screwed up and made it a smidge too deep. Oops. I told you I don't like doing driver recesses. Let's set this in there and see what that does. Ah, yes. Perfect. I like it. I like it a lot. All right, problem solved. Let's just do that on the other side and then we'll be good to go. You always want the drivers to sit flush if possible, Okay. So this goes to the input. I've got everything labeled with, labels. And this is going to go in like this, in here, and then it's going to tuck around into the mounting mechanism, which I designed for it. Sorry I don't have a better view for you, but I'm trying to let you see what's going on here. That thing's going into the notch right there. And then I got to get that screw in. Put in the screw. It's already what would you say? I already drilled got the threads made for it, so it just needs to get tightened up. Number 6 screws. This has a gasket on it. These screws are ready to go in. Well, this project is coming to a close. I'd like to thank John from the John Audio Tech YouTube channel for entrusting me with his 8-inch two-way speaker build. It was a lot of fun, and it was really cool getting to meet him at the speaker design competition earlier this year too. I wish I'd been more awake. I never seem to sleep well when I'm away from home, but I did get some good one-on-one time with him. And what an interesting guy. You know, he's basically self-taught with all the electronic stuff he does on his channel. That just blows my mind, honestly, but he found something that interested him, and he decided that he was going to try and understand it. And now he's an expert at it. And that's exactly what I'm trying to do with this channel. I certainly don't claim to have achieved expert status, as evidenced by my nearly constant screw-ups, but the idea is that I'm not going to be afraid to try something new just because I don't initially understand it, or because I'm afraid I'll fail. You only fail if you fail to try. Dang, that's a good quote. I wonder who said that. I've got a few new things coming up soon on the channel, Lord willing, so stay tuned for that. It should be exciting. Alright, I'll see you next time. Bye now.